Hello, my name is Berger. I am a PhD student at the University of Cambridge, studying how to reconcile agriculture with biodiversity conservation. However, today I would like to present the findings of my master's dissertation. Under the supervision of Professor Yadvinder Mali and Jesus Aguirre Gutierrez, I used a trait-based approach to investigate whether defaunation via the breakdown of seed dispersal networks could have led to changes in tropical forest composition and functioning over the long term. By altering animal-plant interactions, defaunation disrupts forest functions such as herbivory, pollination, seed predation, and seed dispersal. Seed dispersal is likely to be especially affected by defaunation, given that around 80% of tropical forest woody plant species produce seeds that are dispersed by vertebrates. Defaunation is also frequently site-selective, with the removal of the larger species causing a downsizing within the frugivore community. Previous studies have usually either simulated the effects of a decline of large-seeded animal-dispersed tree species on tropical forest functioning, or assessed the effects of defaunation on seedling and sapling recruitment through real-world observations or exclusion experiments. However, it is important to gain an understanding of the long-term consequences of defaunation on ecosystem composition and functioning. Disruptions to the seed dispersal networks caused by defaunation may manifest themselves in shifts in the reproductive functional trait composition of plant communities. So here we investigated whether tree reproductive traits and community composition carry potential defaunation signals across space and time. We obtained vegetation census data from 69 permanent vegetation plots in Ghana and Gabon. All vegetation plots were measured at least twice, which allowed us to estimate the age of each tree during the most recent census, and we then grouped the trees into different age classes or cohorts. We then compiled functional trait data for all the tree species from the literature. This then allowed us to ask whether age cohorts differ in the proportion of animal dispersed trees in each plot. We compiled functional trait data for all tree species from the literature. This then allowed us to ask whether age cohorts differ in the proportion of animal dispersed trees in each plot. And we expected younger cohorts to have a low proportion of animal dispersed trees due to a decline in the number of seed dispersing animals. We also asked whether the seed width of animal dispersed trees differs between age cohorts, expecting to find the average seed size to be lower in the younger age classes due to a disproportionate decline of megafauna and a functional role of dispersing large seeds. We analyzed the data using generalized linear mixed models with plant identity as a random term and age cohort and country as fixed effects. We also fitted an interaction between cohort and country and included a variety of covariates such as precipitation and temperature. We then conducted model selection based on the Bayesian information criteria. The most parsimonious model suggested the proportion of animal dispersed trees differs between age classes, where there are relatively fewer animal dispersed trees in younger cohorts. Similarly, the average seed width of animal dispersed trees was lower in younger age classes, especially in trees that are less than 50 years old. Our findings show that in the tropical forests of Ghana and Gabon, changes in the prevalence of functional traits related to seed dispersal have occurred in a manner that would be expected under increased defaunation pressure over time and a downsizing of faunal frugivores. Our work may contribute towards establishing baselines and setting biodiversity targets, because our work provides a long-term perspective and an insight into the reproductive trait composition that can be expected when there's a relatively intact faunal community. My colleagues and I are currently assessing whether the observed trait changes are indeed likely to be a result of defaunation, or whether other factors such as succession could play a role. Thus, we're including species light tolerances and the age of the forests in the models, as well as the relative abundance of different frugivores taxa across time. We are currently also assessing whether there are any correlations between the reproductive functional traits and non-reproductive plant functional traits. So preliminary results suggest that animal dispersed tree species have a greater wood density than abiotically dispersed species, and the greater the seed size of the animal dispersed tree species, the greater is the wood density. So there are potentially far-reaching consequences for ecosystem resilience with sort of negative feedback loops between defaunation and climate change. And also considerations towards defaunation must be given when drafting effective climate change mitigation strategies. So with this, I would like to thank you for listening, and I'm happy to take any questions.